The legality of using electrical nonmetallic tubing, often abbreviated as ENT, in different areas hinges on local building codes and regulations. In the United States, the National Fire Protection Association, or NFPA, Code 7T, also known as the National Electrical Code, plays a significant role. This code places restrictions on the use of polyvinyl chloride, PVC, conduit in certain hazardous locations. These locations include places of assembly with an occupant load of 100 or more persons. This encompasses theaters, auditoriums, and assembly halls. Also included are aircraft hangars and fuel handling areas. However, there are exceptions. Firstly, ENT can be used in concealed spaces that are not accessible to the public. Secondly, ENT can be used in areas where it is deemed necessary to protect the conduit from physical damage. Thirdly, ENT can be used in accordance with special permission from the authority having jurisdiction. When we look at other areas beyond the United States, the International Electrotechnical Commission, or IEC, generally allows the use of PVC conduit in most electrical installations, but it's crucial to remember that local regulations may vary. Canada, under the Canadian Electrical Code, has a system similar to the FPA Code 70, with restrictions on PVC conduit in certain hazardous locations. In the United Kingdom, the BS 7671 IET wiring regulations are similar to the IEC, but there are some additional restrictions on the use of PVC conduit in certain outdoor applications. There are fundamental reasons why these restrictions exist. PVC conduit, when burned, releases hydrogen chloride gas. This gas is toxic and can be fatal if inhaled. This is the primary reason why its use is restricted in areas where there is a high risk of fire or where large numbers of people gather. However, there are exceptions to these restrictions. In some cases, exceptions to the restrictions on ENT use may be granted by the authority having jurisdiction. This is usually done when it is deemed necessary to protect the conduit from physical damage or when there is no other viable alternative for the electrical installation. To ensure safety in all electrical installations, it is always best to consult local building codes and regulations before using ENT. If there is any doubt about its suitability, it is advisable to use a different type of conduit that meets the applicable requirements. It's vital to consult the specific codes and regulations applicable to the location where the electrical work is being performed. Regulations can vary significantly from one jurisdiction to another. Understanding the occupancy classification of a building or space is crucial. Places of assembly, such as theaters and auditoriums, have stricter regulations due to the potential for large numbers of people to be exposed to hazards in the event of a fire. When selecting conduit, consider the environmental conditions to which it will be exposed. For example, if the conduit will be exposed to direct sunlight, it should be made of a material that is resistant to ultraviolet radiation. If the conduit will be buried underground, it should be suitable for direct burial applications. Always verify the listing and labeling of the conduit to ensure that it is suitable for the intended application. Listed unlabeled products have been tested by a recognized testing laboratory to ensure that they meet applicable safety standards. Authorities having jurisdiction often have the final say on whether or not ENT can be used in a particular application. It is important to work with these authorities to ensure that the electrical installation meets all applicable requirements. Alternatives to PVC conduit include metal conduit, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. These types of conduit do not release toxic gases when burned and may be required in certain applications. Another alternative is flexible metal conduit, which can be used in locations where flexibility is required. When installing ENT, it is important to follow the manufacturer's instructions and all applicable codes and standards. This includes properly supporting the conduit, using the correct fittings, and ensuring that the conduit is properly grounded. Conductors must be properly sized for the intended load. Overloaded conductors can overheat and cause a fire. All electrical connections must be made properly and securely. Loose connections can cause arcing and overheating, which can also lead to a fire. Grounding is essential for electrical safety. A properly grounded electrical system provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Regular inspections and maintenance of electrical systems are important to identify and correct any potential hazards. This includes checking for damaged or deteriorated wiring, loose connections, and other problems. Understanding the specific requirements for hazardous locations is critical. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Different types of conduit and wiring methods are required in hazardous locations to minimize the risk of ignition. When working with electrical systems, it is important to use personal protective equipment such as safety glasses, gloves, and insulated tools. This equipment helps to protect people from electric shock and other hazards. Never work on live electrical equipment unless it is absolutely necessary. If it is necessary to work on live equipment, take extra precautions to protect yourself from electric shock. Always de-energize electrical equipment before working on it whenever possible. Lockout/tagout procedures should be followed to ensure that the equipment remains de-energized while work is being performed. If you are not qualified to work on electrical systems, hire a qualified electrician. Working on electrical systems can be dangerous, and it is important to have the necessary training and experience to do the work safely. The National Electrical Code, or NEC, is updated every 3 years. It is important to stay up to date on the latest changes to the code to ensure that electrical installations are safe and compliant. Many resources are available to help people learn about electrical safety. These resources include training courses, publications, and websites. Continuous learning is essential for anyone who works with electrical systems. Technology is constantly evolving, and it is important to stay up to date on the latest advancements and best practices. Always prioritize safety when working with electrical systems. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and others from harm. In summary, the use of ENT is governed by a complex interplay of national and local codes, occupancy classifications, and specific site conditions. Always consult the relevant authorities and qualified professionals to ensure compliance and safety. When considering alternatives to ENT, factors such as cost, durability, and ease of installation should be taken into account. Metal conduit, for example, offers superior protection against physical damage but may be more expensive and difficult to install. Understanding the fire resistance ratings of different types of conduit is also important. Fire resistance ratings indicate how long a material can withstand exposure to fire before it fails. In some applications, fire-resistant conduit may be required to protect critical circuits. Proper selection and installation of electrical boxes and fittings are also essential for electrical safety. The electrical boxes and fittings must be compatible with the type of conduit being used and must be properly grounded. When running conduit through walls or floors, it is important to seal the openings to prevent the spread of fire and smoke. Fire-stopping material should be used to seal these openings. The use of surge protection devices is recommended to protect sensitive electronic equipment from damage caused by voltage surges. Surge protection devices should be installed at the service entrance and other strategic locations throughout the electrical system. Regular testing of ground fault circuit interrupters, or GFCIs, is important to ensure that they are functioning properly. GFCIs are designed to protect people from electric shock by interrupting the circuit when a ground fault is detected. The use of arc fault circuit interrupters, or SIs, is also becoming more common. SIs are designed to protect against fires caused by arcing faults. In addition to the NEC, other standards and codes may also apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. The design of electrical systems should take into account the potential for future expansion. This may involve installing larger conduit or providing spare capacity in electrical panels. Proper documentation of electrical systems is essential for maintenance and troubleshooting. This includes creating accurate as-built drawings and maintaining records of all electrical work that has been performed. The use of energy-efficient lighting and equipment can help to reduce energy consumption and lower utility bills. Energy-efficient lighting and equipment may also qualify for rebates or incentives from utility companies. The installation of renewable energy systems such as solar panels and wind turbines can help to reduce reliance on fossil fuels and lower carbon emissions. Renewable energy systems must be installed in accordance with all applicable codes and standards. Proper disposal of electrical waste is important to protect the environment. Electrical waste should be recycled whenever possible. It is important to be aware of the potential hazards associated with working around electrical equipment, such as power lines and transformers. Always maintain a safe distance from electrical equipment and never touch anything that is suspected of being energized. In the context of the question, it is crucial to remember that exceptions to restrictions on ENT use are not automatic. They require a thorough assessment of the specific circumstances and approval from the authority having jurisdiction. The justification for an exception must be well documented and supported by sound engineering principles. Furthermore, the use of ENT in concealed spaces does not necessarily mean that it is safe to ignore fire safety concerns. The concealed space may still contain combustible materials, and a fire within this space could spread rapidly if not properly contained. The type of construction also plays a role in determining the suitability of ENT. In fire-rated construction, for example, the use of ENT may be restricted to maintain the integrity of the fire-resistant barriers. The presence of hazardous materials or processes in a building may also affect the suitability of ENT. In areas where flammable liquids or gases are stored or used, more stringent requirements may apply to electrical installations. The age of an electrical installation can also be a factor in determining the suitability of ENT. Older electrical systems may not meet current safety standards, and the use of ENT may not be appropriate in these systems. A thorough inspection and evaluation of the existing electrical system is necessary before any modifications or additions are made. The cost of electrical material should not be the sole factor in determining the type of conduit to use. Safety and performance should always be the top priorities. In some cases, the long-term cost of using a less expensive material may be higher due to increased maintenance or replacement costs. The availability of qualified electricians and contractors is also an important consideration. Not all electricians and contractors are familiar with the latest codes and standards, or with the proper installation techniques for different types of conduit. It is important to hire a qualified professional who has the necessary experience and expertise. The reputation of the manufacturer of the ENT should also be considered. Reputable manufacturers typically have rigorous quality control processes and provide excellent customer support. It is important to choose ENT from a manufacturer that has a proven track record of producing high-quality products. The warranty offered by the manufacturer is also a factor to consider. A longer warranty provides greater assurance that the product will perform as expected. The ease of installation of the ENT can also be a factor in determining its suitability. Some types of ENT are easier to install than others, which can save time and money. The flexibility of the ENT can also be a factor to consider. Flexible ENT can be easier to install in tight spaces or around obstacles. The weight of the ENT can also be a factor to consider. Lighter ENT can be easier to handle and install, especially in overhead applications. The color of the ENT can also be a factor to consider. Different colors of ENT may be used to identify different types of circuits. The labeling on the ENT should be clear and easy to read. The labeling should indicate the type of ENT, the manufacturer's name, and any applicable ratings or certifications. The packaging of the ENT should be designed to protect the product from damage during shipping and handling. The packaging should also include instructions for proper storage and handling. The availability of accessories for the ENT can also be a factor to consider. Accessories such as couplings, connectors, and supports are necessary for a complete installation. The compatibility of the ENT with other electrical components is also important. The ENT should be compatible with the wire, cables, and other components that will be used in the electrical system. The resistance of the ENT to chemicals and other environmental factors should also be considered. In some applications, the ENT may be exposed to harsh chemicals or extreme temperatures. The impact resistance of the ENT should also be considered. In some applications, the ENT may be subject to physical impact. The ultraviolet resistance of the ENT should also be considered. In applications where the ENT will be exposed to sunlight, it should be made of a material that is resistant to ultraviolet radiation. The moisture resistance of the ENT should also be considered. In applications where the ENT will be exposed to moisture, it should be made of a material that is resistant to moisture. The flame resistance of the ENT should also be considered. The authority having jurisdiction may require the use of flame-resistant ENT in certain applications. The smoke density of the ENT should also be considered. In a fire, the smoke density of the ENT could affect visibility and make it more difficult to escape. The toxicity of the ENT should also be considered. Some types of ENT release toxic fumes when burned. The authority having jurisdiction may restrict the use of ENT that releases toxic fumes. The cost of the ENT should be considered in relation to its overall value. The cheapest ENT may not be the best choice if it does not meet the required safety and performance standards. The environmental impact of the ENT should also be considered. Some types of ENT are made from recycled materials or are recyclable themselves. The regulations and standards surrounding ENT, PVC, and other conduit types are in place to mitigate risks and ensure public safety. Always prioritize safety and compliance when working with electrical systems.